Hello, microbiology students. Welcome back to the second part of our parasitic helminths lecture. Hope you're doing okay today. We have discussed already the cestodes, which are the tapeworms, and we've already talked about our nematodes, which are our flukes. And so what we have left are the nematodes. And so nematodes, this is a phylum of non-segmented roundworms. The majority of them, or all the ones we're talking about, are going to be dioecious. As far as body shape, it's kind of telling you they're round. They have a cylindrical tapered body. These have a complete digestive tract running from mouth to anus. However, it's not that well developed. Once again, the number one developed system in a parasitic helminth is going to be that reproductive system. Many of these that fall in the phylum Nematoda are actually free-living. They live in soil, they live in water, meaning they're not all bad. Some of the ones are their parasites, and those are the ones we're going to talk about. So that's where we're headed. All right, this is not going to work. There we go. All right, so if you can, hopefully you've printed this out. So we are just going to work our way through this table. I do want to draw your attention to, so I've given you disease characteristics, and the usual ones, if they're living in the gastrointestinal tract, you're going to have abdominal pain and diarrhea or vomiting or things like that. The big thing, I don't expect you to know all of these or memorize all of the disease characteristics. The ones I really want you to know, I put into the Quizlet. I do want to draw your attention to this down here because I didn't really put in a separate slide for it. But you'll see some of these can have no symptoms or fewer no symptoms, or they're really just very generalized symptoms, so people don't realize they have a parasitic infection. But if someone has a very high worm load, so lots of worms in their body, obviously that is going to increase the severity of symptoms. And two, these are parasites, so they're drawing nutrients from the host. So the more worms, the more nutrients they're going to take. This really hits children very hard, so a lot of times it can cause, through development, failure to thrive, intellectual disability, and then just, like I said, their nutrients are being sucked from them. So those are just sort of general things. I didn't make a special slide for it, but I did kind of include it. I just kind of wanted to draw that to your attention, just for your understanding. Okay, so our first roundworm infection that we're going to talk about is called ASCARIASIS. It is what is called an STH by the CDC. It is a soil-transmitted helminth. This is the #1 worldwide parasitic infection, 807 million to 1.2 billion cases. So they believe that like 15% of the whole world's population is infected with ascariasis. And so this is a map. Once again, for helminth parasitic infections, Africa is always the hardest hit. Then also high parasitic infections in South America and in Asia. Ascariasis is so high. This is one that is actively treated by the World Health Organization. And they really just look for the proportion of children that have it. And they go into villages where there are 20 to 50% of the population that has these diseases. Has ascariasis, and what they'll do is they'll just do a biannual treatment. They know that it's prevalent, endemic in that area. There's poor sanitation in these areas, so they just kind of come in twice a year and basically deworm everyone. Okay, so let's watch about the life cycle of ascariasis.
A larva hatches out from an infective egg laid in the intestine of the host. It then penetrates the intestine walls and is carried through the blood vessels to the lungs. From the lungs, it moves to the lumen of the respiratory tract and then into the throat, which becomes swollen as a result of coughing. From the throat, the larva returns to the small intestine where it matures. Female Ascaris lumbricoides lay more eggs, up to 200,000 a day, in the lumen of the intestine. The eggs are excreted in the feces, and once in the external environment, they reach the stage of the so-called invasive egg containing a larva. Only then do they become infective. Infection occurs when the eggs reach the alimentary tract, for example, when the host consumes contaminated fruit or vegetables. Once in the small intestine, the eggs begin to develop, thus completing the life cycle of Ascaris lumbricoides. A larva
Sorry about that. Okay, so it is going to be through soil, through feces, in the soil, using that water on vegetables, but basically this is going to be transmitted through the fecal-oral route. And so, like I said, it's very high in parts of the world, and the World Health Organization goes in. And so this is a child. She has a heavy worm load. So these are going to be living in the intestine. So this is probably fluid and worms. I got this picture from another professor. So this jar alone is all the adult worms that were collected from one rural village in Bangladesh in a single day. So like I said, this is the #1 most prevalent helminth parasite in the world. Like I said, it's a soil-transmitted helminth, and so Ascaris, hookworm, which we're going to talk about next, whipworm, we're not really covering it. That's just another one. So they're caused when they just put them under this heading of soil-transmitted helminths. The eggs are going to be present in human feces, so these are places without proper sanitation. So basically washing their clothes, drinking water, and then of course defecation all kind of occur right in the same places. So sanitation is poor. And I'm not making a joke, it's actually kind of true. The best invention ever would be an outhouse that sort of restricts the area where humans defecate. Like I said, 1.5 billion, that's a whole lot of people they think are infected with soil-transmitted helminths. And like I said, it really, excuse me, if this infection is in children, it does leave them, nutritionally and therefore physically impaired. They don't have the nutrients to grow properly and develop properly. And like I said, control is based periodically by deworming, eliminating basically entire villages, trying to educate them to prevent that reinfection and improve sanitation, to reduce that soil contamination. Like I said, people, they're not wearing shoes. Little children in particularly, they play in the dirt, they stick their fingers in their mouths. Feces is used to fertilize crops. And so when the vegetables or the leaves are picked, if they're not washed properly, the eggs are still on them. There are safe and effective medicines that are available to control infection, but we're going to watch another video later talking about some other parasitic diseases. The public or these villages, they're not always receptive to taking the medication. So there's just a lot of obstacles in eradicating these diseases in certain areas. Okay, so just kind of back to Ascariasis. It is one of the larger roundworms. The females can get up to be about a foot long. Like I said, they are just releasing eggs into the lumen, that open space in the small intestine, up to 200,000 a day. When the worms are ingested, they go through stomach, and they're going to burrow through the intestine. And then they get in the bloodstream. And from the bloodstream, then they're going to enter the pulmonary circulation. They're basically going to burrow into the air sacs of the lungs, and they're going to work their way up the respiratory system. So through the bronchioles, bronchi, the trachea, until the cough reflex is stimulated. Excuse me. And then they're going to be coughed up and swallowed back into the intestines. And it seems kind of weird, like, okay, you started in the intestines, but they have to make their journey of maturation process and go back to the intestines, where they mature into the adult worms, and they mate, and then that female releases all of the eggs. A few worms are tolerated. If there's a lot of worms, when they go through this stage of being coughed up, if there's a whole lot of worms, can actually, cause choking issues with the respiratory system. If there are a high volume of worms in the intestine, you can get everything from total obstruction of the intestines, blocking the bile ducts coming from the liver, peritonitis, and that fluid build up in the abdominal pelvic cavity. And so just keep in mind that worms are feeding on the nutrients being passed through that digestive tract. Okay, and so here is this is from your textbook, and just kind of walks you through it. One thing that I just want to bring up too, the worm eggs, they actually think they're really stable. One article I read said that they believe that these eggs can just persist in soil for even up to 10 centuries. I don't really know where they're getting that from, but they are very stable in soil, which means it's hard to get rid of, and with poor sanitation, you're just going to get reinfection of the population. It's always showing you the digested eggs, and then they're going to burrow through into the bloodstream, and then they're going to go to the lungs, and they're going to work their way up. They're going to get coughed up and then swallowed back down into the intestine, and that's where the mature worms live, reside, mate, and then release the eggs to start the whole cycle all over again. Okay, so our next one is going to be hookworm. And this too, a lot of people are infected with hookworm, so about 600 million infections per year. There are two different worms that cause hookworm. Actually, there's three, but we're just going to talk about two. Necator americanus and Ancylostoma duodenale. And I always love that word, just kind of throw a little Italian flair on there. It's going to have a similar life cycle. Once again, the eggs are going to be shed in feces in soil, so this is a soil-transmitted helminth. In this case, instead of being ingested, so instead of the fecal-oral route like ascariasis, these larvae are going to burrow into the skin. So people are walking around where humans have defecated, and they're walking around barefooted, or they're tending the garden that's being fertilized with human feces. Either way, the larvae are going to burrow in through the skin. Through the skin, then they get to the bloodstream, they're going to migrate to the lungs, and once again, then they're going to penetrate the air sacs. They're going to work their way up the respiratory system until they're coughed up and swallowed. These hookworms, they are blood-feeding parasites. They're going to be taking the nutrients. Once again, few worms, that's going to be tolerated with either mild or no symptoms. But if there is a larger worm load, since they are hooking and latching on to the mucosa of the intestines, mucosal damage, they are taking blood. They're taking the hemoglobin and the iron, so you can have anemia, you're going to get weakness, fatigue, and then once again, a child in this environment, she has a high worm load, she's going to have failure to thrive. So that's hookworm. And just kind of showing you the life cycle, we just kind of pretty much already discussed it. There are different worms that cause hookworm, that's just a general term, and you can see they look like they have hooks for their attachment, and so it's actually the shape of the hooks that they help identify which type of worm is causing the infection. But we're just going to go Necator americanus and Ancylostoma duodenale as our two causative agents of hookworm. Okay, so these two kind of had some similarities. They're both soil-transmitted helminths. Something that's unique compared to the other ones we've talked about, they only involve humans as hosts. The next one, we're going to talk about pinworm coming up. That one too, it only involves humans. So humans are the definitive host. There's not an intermediate host. In this case too, both of them are going to end up in the bloodstream, ascariasis through ingestion, and then hookworm through penetration of the skin. But they both end up in the bloodstream. They both then go to the lungs and the pulmonary circulation. They're going to work their way through the respiratory tract. They're going to get coughed up and swallowed back into the intestine where they mature into adults. They're going to sexually reproduce, and then eggs are released through the feces. So they have those things in common. Okay, so pinworm. Oh, everyone wants to talk about pinworm. Okay, this one you either already have had contact with if you have children, possibly, or at least maybe you've heard of it. It is estimated that 30% of children, about 16% adults are infected with pinworm. The causative agent, we're still talking about roundworms, Enterobius vermicularis. And so this word is kind of telling you entero, enteric, entero always means intestine. Vermicularis, worm, vermiform means worm, so intestinal worm. It is the #1 United States parasite. This too, just like ascaris and hookworm, it's only in humans. There are no other hosts. It mostly is going to infect children, just because children typically touch their butt and stick their hands in their mouth, basically. And then institutionalized individuals where hygiene is not good, whether it be prisons or senior centers or healthcare facilities where daycares where there just isn't really good hygiene. So it's going to be through fecal oral ingestion, also through fomites. Remember, those are inanimate objects, so they can live a while on surfaces, and even through inhalation. So let's pop over here. So we have embryonated eggs. It's going to be the eggs that are going to be ingested. The larvae are going, so it's going to make its way through the stomach, and the larvae are going to the larva hatch, in the small intestine. And so you have the adults, so these are dioecious, a female and a male. And then what happens is they mate, and then the gravid female, meaning she's got some eggs she wants to release, is going to crawl out of the colon. This is a nice picture of someone's anus, by the way, and these tiny little white things, these are the female pinworms. They tend to migrate at night, and causes intense nighttime anal itching. They can itch during the day, so if you see small children with their hands scratching their butt, they may have a pinworm infection. So if you are living in the home with someone with a pinworm infection, someone doesn't wash their hands, people aren't sticking their hands in their mouth, it's a way that it can be transferred, and even through inhalation of those eggs. And so that's why the number one U.S. parasites. Pinworm caused by Enterobius vermicularis. Okay, so our next one, just working our way down our table, if you have that in front of you. So the disease is trichinelosis or trichinosis. Both are correct. I think the nellosis, it just got kind of long, and some people truncate it. Both are fine. Just for clarity, I just stuck with trichinellosis because the causative agent is Trichinella spiralis. And this is a picture of an encysted Trichinella spiralis, and notice it's a spiral, so that's how it got its name. It too is going to be through transmission of meat. So undercooked meat that has viable cysts in the muscle. And usually this is going to be through pork. This is, you can see this little cycle over here, the domestic cycle. If pigs are fed meat scraps, or if we're talking about rodents through cannibalism, however that occurs, then the larvae are going to encysted in the muscle of the pig. Humans are going to eat that encysted muscle if the food is not cooked properly, if it hasn't been deep frozen for very long, or irradiated. Then once that meat is ingested, the larvae are going to be released in the small intestine. The larva can also burrow out and encysted in muscle in the human as well, but we are the definitive host. We have the adults in the small intestine. And then like I said, they're going to encysted into the larva. And so that's how someone gets trichinelosis. As far as, this is called the sylvatic cycle, it also occurs in other mammals out in the wild. So yes, and technically if you're going to eat some polar bear meat or some bear meat, you could also get it from there. But for the most part, it's going to be through the ingestion of pork. Those larvae, once you have the infection, they do migrate to skeletal muscle, but they can also migrate to the heart or to the central nervous system. So it's not chest muscle. We get it from eating meat, which when you eat meat, you're eating muscle. Okay, so in this case, I'm going to ask this as a quiz question, but are we the intermediate host or the definitive host? This one's kind of confusing, but just kind of remember your definitions. Intermediate host houses the immature form that asexually reproduce, and the definitive host houses the mature form which reproduces sexually. Okay, so our next one is going to be, the disease is filariasis, and another name for that is elephantiasis. So the causative agent, another one of my favorites, so Leucocuria bancrofti. This is going to have an arthropod vector through the bite of a mosquito. So this is the life cycle for filariasis. And so it begins with the bite of a mosquito. And so through When the mosquito, only the female, takes a blood meal, they inject the microfilaria into the bloodstream. And then those microfilaria, they are going to circulate and they're going to mature into adults in the lymphatic system. And so our lymphatic system runs adjacent to the cardiovascular system, and it's basically our sewer system. The job of the lymphatic system is to soak up excess tissue fluid and return it to the bloodstream. And so that's where the adult worms are going to live, male and female. They are going to reproduce and produce these microfilariae, which are going to migrate into lymph and blood as well. And so then a mosquito comes and takes a blood meal, and that's where the mosquito picks up the microfilaria. And then they are going to go to the midgut, and we're just going to have immature stages in the mosquito, and it's going to end up to the mosquito's proboscis in their head. And so that's how a mosquito then can transfer from one human to another. So the mosquito is the vector and also the intermediate host. Notice these are all immature forms. All right, let's learn about filariasis.
Hi, my name is Tiana. I live in London and I work for GlaxoSmithKline within the Global Disease Programs Unit. I want to share a story about one of our patients with all of you. Meet Jetta. Just like me, she's a woman in her 30s, but her home is in West Africa, a region significantly affected by mosquito-transmitted disease, and her story couldn't be more different from mine. Things started off much the same. She lived with her family and helped her mother work when she could. She played with her friends and even had dreams of a great future. But as she entered her teenage years, life for Jetta changed forever. Over time, her legs became swollen. At first she dismissed it as nothing, but as it continued, she realized something was very wrong. And soon, her days and nights were plagued with unshakable fevers and headaches. She had contracted a serious infection that wouldn't respond to any medication. People shunned her, accusing her family of witchcraft, and Jetta did not know where to turn. In neighboring Burkina Faso, hope was in sight. Jetta's brother had learned of a program helping people like her. It was there she discovered her condition wasn't down to witchcraft. She had in fact contracted lymphatic filariasis, a parasitic disease transmitted across Africa by mosquitoes. She was given a combination of antiparasitic drugs, one of which was albendazole, donated by GSK, and the other, mectizan, donated by MSD. Though her physical condition would remain permanent, it took just a single dose of these drugs to help clear the parasite from her bloodstream. In 2013, I traveled to Burkina Faso, where I met a group of LF sufferers. I will never forget a smile which stood out from the crowd. It was Jetta's. Though we didn't speak the same language, her newfound joy in controlling her symptoms was palpable, and her beauty and strength, they were humbling. When it was time to say goodbye to Jetta, I left her with a small token of my gratitude, but she left me with far more valuable gift: her smile and a new understanding of a condition which currently affects over 100 million people. At GSK, we are dedicated to working together with the World Health Organization and all of our partners to eliminate lymphatic filariasis, ensuring that people need not suffer in the same way that Jetta has. It was incredible to see firsthand just how those efforts are transforming lives and indeed making people smile.
Okay, so that kind of gave you a nice little personal story behind that. Yeah, so millions of people have lymphatic filariasis, and that blocking of lymphatic ducts leads to the swelling of appendages. Usually it's the lower extremities or the genitals. It can also be an upper appendage. And so that single drug, or those two drugs given together, can wipe out the parasite in the bloodstream, but the condition elephantiasis remains. And I don't know if you ever watch River Monsters, but I caught this on YouTube. It's Jeremy Wade. So there's a difference. They can be cured of the infection, but there is actually, it was believed that you could not be cured of elephantiasis, that you had to remain with that appendage just swollen and in that state. But Jeremy's got some good news. Okay, so I love Jeremy Wade. Yeah, so there's millions of people affected. Even if they get the drug treatment, then they still carry around those swollen appendages. After the mosquito bite, people can be asymptomatic for years. Like I said, if you've had AP2, hopefully you kind of remember what the lymphatic system is for. But this is the lymphatic system, all these green vessels. And like I said, their job is to take excess fluid and return it back to the bloodstream. And then the kidneys filter out the blood, and then all waste material or excess fluid is eliminated in urine. And so that's the treatment. Basically, this doctor is taking the time, and he's built these corsets to basically squeeze the fluid so it is forced back into the bloodstream so it can be removed from the body, but it takes quite a bit of time. So you have that swelling. It's called lymphedema because these worms are in the lymphatic system. So that swelling edema is caused by those worms. So lymphedema. And then the skin has to stretch and accommodate, and it thickens. And so that's where that name elephantiasis comes from. And like I said, usually it's going to be the genitals and the lower extremities, but I have seen pictures. It can also be an upper appendage. Okay, so I believe we are on our last helminth. So this disease is called river blindness, or it's called onchocerciasis. The causative agent is a nematode, because we're talking all about nematodes this time. It's a roundworm, not segmented. So Onchocerca volvulus. Your textbook has a little breakout box, which I'm not going to ask about, but it was kind of interesting that it's actually not the worm. These worms are also being parasitized by a bacteria, that they're the ones actually causing the disease. But that's just a side note. Don't worry about it. If I say what is the causative agent, give me the worm name. Transmission, there's a vector through the bite of a black fly. We're going to watch a YouTube in just a minute. And so it can cause first a skin rash and lesions, and then it can progress into that vision impairment and blindness. And so once again, it's going to be through microfilaria, are going to be injected through the bite of a black fly. So very similar to our life cycle of Leukocuria bancrofti, but in this case, instead of going lymphatic system, they are going to stay in the skin, and then the microfilaria can find their way around to other tissues. So let's see. This too is another heartbreaking story.
In the isolated villages of Tanzania, rivers are a source of life. They are also a source of disease. This man is a corn farmer and father of 5, but for the last 3 years he has not been able to see and cannot work. He has river blindness. River blindness, or onchocerciasis, affects an estimated 4 million people in Tanzania alone. On a recent trip to the southern highlands of Tanzania with the World Health Organization, we visited isolated villages where innovative efforts are underway to treat the disease, but it presents some unusual challenges.
In this particular village, the only source of water supply is this river, and they need water from this river for washing themselves, for washing their clothes.
But there is a major problem. This river is infected with black flies which carry the parasitic worms that cause river blindness. The flies breed in clean, fast-moving water, which makes it difficult for villagers who depend on the river to avoid. The fly bites introduce worms into the body, where they form nodules under the skin and quickly reproduce, creating millions of offspring. Dr. Wade Kabuka, an ophthalmologist by training, has been working on river blindness in the Rovuma region for nearly a decade. He said, we're going to see a man who
has suspected signs of skin lesions which are suspected to be signs of onchocerciasis.
The symptoms of river blindness can be debilitating, ranging from severe itching that can cause people to lose sleep for years at a time, to epilepsy, and ultimately to blindness. This corn farmer began to lose his sight 3 years ago. Now he is blind. He is on medication, but still has such severe itching that he can no longer sleep through the night. He hasn't slept for a year?
Yes, no, he can sleep for maybe for 3 hours.
Epilepsy can also be a side effect of the disease. The farmer's son, who is 22, suffers from seizures 3 times a month. For the last decade, the World Health Organization has been working with public health officials throughout Africa to come up with innovative ways to treat the disease. In Tanzania, health officials travel through isolated villages, recruiting a network of community organizers to assist in treatment. They work to distribute the drug, known as Mectizan, which was originally developed as a veterinary medicine and is given away free by its manufacturer, Merck. The drug stops the worm from breeding but does not kill it. Infected people must take the medicine for 15 years, the life of the worm.
The prevalence rate for Litoa village is 98%.
98%, so probably all these people are infected.
Yeah.
In order for the drug to halt the spread of the parasite, the entire village must take it for the full 15 years. Otherwise, the worms will keep breeding and reinfect humans. But getting people to take the drug, which can cause severe reactions at first, is often difficult.
There are a few people in the community who refuses to take the drug. Those are the ones who are going to continue spreading the disease in the community.
Many people fear that the drug will sterilize them.
People was generated a false idea that Mectizan is terminating libido.
Others prefer to rely on local healers.
Yes, he said he went to the witch doctors.
Dr. Kabuka says that getting authorities to fund river blindness treatment programs can be difficult, especially when they are in competition for limited funds with high-profile diseases like HIV/AIDS. Nearly 18 million people worldwide have river blindness, most of them in Africa. It is the world's second leading cause of preventable blindness. For now, these community-based programs are the best hope that the people of Tanzania have.
Okay, so it's a problem wherever the black fly exists because that is the vector. And so it has limited distribution worldwide. Like I said, it's still 18 million people worldwide, 4 million people just in Tanzania, and hopefully that YouTube kind of shows you the challenges into eradicating these helminth parasites. To having to take a drug for 15 years, we can barely get people to do things for days. And then to just the distrust and just lack of knowledge just makes it hugely, just really big obstacles in eradicating these diseases. Okay, so we've made it through all of our helminth parasites, and so we just have arthropod vectors left. And we've talked about a vector and its job in transmission of disease. So arthropods include insects and arachnids. Insects, by the way, have 6 legs. Arachnids are like spiders or ticks. They have 8 legs. the vectors and therefore the disease are going to be limited by the geographic range of the vector. And usually if you can eliminate the vector, you will eliminate the disease. Since society has spread, we have humans living in different places of the world now, and so that can introduce them to a vector that previously has not seen humans before, so it leads to emerging diseases. And we kind of talked about that with Lyme disease and the ticks that transmit that infectious agent Borrelia burgdorferi. Like I said, really, if you can prevent the bites from these vectors, it helps to control and prevent disease, and so that's why the whole global efforts to control mosquito populations, distribute, bed netting. If you wear clothes or insect repellent, that's going to prevent it. So I don't care. Your book goes into it. I think your lab book does too. I don't care what genus or species the mosquito is. I do want you to know that malaria, filariasis, and these viruses, West Nile yellow fever, dengue fever, which we'll talk about in the next unit, are all transmitted by mosquitoes, and it's only the females that bite. We discussed the protozoan parasite that causes African sleeping sickness. That is going to be transmitted by the tsetse fly. We just talked about river blindness, onchocerciasis, that is transmitted by the black fly. And then going way back to, it seems like a long time ago, the bacteria Yersinia pestis was transmitted by a flea, which caused the plague. And so just kind of, I think these are fair game on your exam. Okay, so at the end of this, you have some additional YouTube links below this content if you're just working down our virtual class. This is going to end the content for exam 3. I realized on the original syllabus we were going to include viruses in this exam, and I'm not. We have plenty, I think, for this one. And so remember, this exam is going to be over fungi, protists, and helminths, all of medical importance. I did make you a Quizlet for each one of these topics. Do not get Quizlet dumb. Do learn the information on the cards. I realize it's challenging that you got shifted to online, but we can do this. Hopefully, if you look at the Quizlets, that's going to help you immensely on your lecture exams. As always, I'm here if you need me. Enjoy your day, and I'll be back.